Hello, today we are going to introduce to you our BMS system. This is our 3 to 24 series BMS. The BCU and BMU is built together, 2-in-1. We can see in the screen, our BMS has many advantages, and for example, high voltage detecting accuracy, high current detecting accuracy, and 3 high temperature detecting accuracy, and so on. And we made a test bench for the BMS. This is our BMS, and here is the power, low voltage power supply for the BMS. And this is our battery pack. This is a 24 series battery pack, and the capacity is 22 Ah, and total voltage of this battery pack is rated voltage is about 72 volt. And here is the high voltage PDU. This is the fuse, and then go to a manual switch. This switch is only for bench testing, and then go to the pre-charge relay, and it goes through resistance for the pre-charge, and then connect to the this is the discharge relay, and here is the charge relay, and this is the main negative relay. And we also have a current detector to detect the current of the battery system. We can see our discharge relay connect to the loading. This is the discharge relay loading and connect to our drive system. This is a 15 kilowatt rated drive system for the 2-ton full truck. This is the motor controller. The motor controller is integrated with VCU function, vehicle control function. And here is the 15 kilowatt rated drive motor together with the electric axle, and total gear ratio of this axle is 17.5. And the first part we will show to you how the BMS work. First step, we need to turn on the low voltage supply for the BMS, and the voltage supply of the BMS is 12 volt. So we can see the voltage now is 17.2 volt. It's a normal voltage for the BMS. And then we connect, we can switch the button, and then the system will be start to work. And we have put some indicator lights on our test bench, and this one is for the pre-charge, and this one is for the main positive and main negative, and charge and cooling. Each light means if the light is on, it means the connector, the relay is closed, is connected. Okay, you can keep the camera here. Now I press the button. We can see the main negative and the cooling, main negative on, and charging is on, because Now the charger, the 3 kilowatt charger is connected to the BMS system. We can open. We can have a look on our hot software. We can see in the screen now the charging current is about 5.7 amps at the voltage of 82.3 volt, and let me change to English. All the cell voltage we can read on the screen, and the temperature of the battery pack is also shown on the software, and the maximum voltage of the battery pack and the minimum voltage of the battery pack is also shown on the software. And in our software, customer can set many parameters according to the application. And this software is also support to OTA. Customer can upgrade the firmware by internet, and also it also can save the record on the PC. Okay, now it's charging, but our battery SOC now is 99%. It's quite enough of power. So I will stop the charging first. We can press this button for more than 3 seconds, and the battery, the system will be off. Now I disconnect the charger. This is the charger power. I disconnect the charger power, and then now I start the battery again. Press the button for a short time. We can see now the main negative relay is on, and the main positive relay is not closed. So let me check. Maybe the now it's on. It's on. Maybe just now the charger still connect. The charger communication. The charger power is off, but the charger have the capacitance, so it still have some power inside, and the charger is connected to the BMS with the CAN network. So when I turn off the power of the charger, it still have some communication goes through the BMS. So the BMS will just turn on the main positive a little bit late. Now the main positive and main negative is on. So let me show you again. We turn off the system. Now I turn it on again. Let's check how it start. We turn on the main relay first, main negative first, and then it turn on the pre-charge relay for a very short time, and it turn on the main positive relay. So now the main positive relay is on. We are going to drive our system to see how the battery discharge. I turn on the system. Turn on the system. I go to D gear, and I press the accelerator. Now we can see the instruction current is about 30 to 30 amps. Just now we can see the discharge current is more than 1C because this battery is 22 amps. Just now the maximum discharge current is just reached 40, so nearly around 2C of the discharge rate. This is the charging test and the discharge test of our BMS. Also the connect of our BMS, and in this BMS system we also have the cooling function. It means that when the temperature goes to certain degree, the cooling will start. Now we can read in our PC application. The temperature now is 20 and 21, and we can see the cooling relay is off. Now the light is off. So I use a heater. I use the heater to make the temperature goes up. This is the temperature sensors. We have 6 temperature sensors in the BMS. Now the temperature is going up. Temperature of the sensor is going up. Okay, when you go to 60, we can see that now the cooling light is on. It means that the cooling relay is on, and the BMS is sending some warming beads, and the temperature is dropping when it's cool down, and the cooling relay now is off. How we can set the cooling temperature? We can set the cooling temperature in the setting. We can see down here. Battery overheat protection 60. Battery warm temperature. Battery overheat warm temperature is 55. Battery overheat protect is 60 centigrade. It means that when the temperature goes to 60, the cooling will start to work to turn on the relay of the cooling so the cooling system will start to work. Okay, thank you for watching.